Hello dear students. So in this video we will be discussing work energy power PYQ from January 2024 attempt. Let us start. So the first question that we have, it says two bodies of mass 4 gram and 25 gram are moving with equal kinetic energies, right? Question is there for you people, right? Let us see. Two bodies of mass 4 gram and 25 gram are moving with equal kinetic energies. The ratio of magnitude of their linear momentum is, two bodies, kinetic energies are same, masses are given to us 4 gram and 25 gram. Kinetic energy same, they are asking us the ratio of momentum. Fine. So what do we know? What is our relation between kinetic energy and momentum? Relation is kinetic energy is equals to P square by 2m, right? This is what is the relation between kinetic energy and linear momentum. We'll substitute. So K1 can be written as P1 square by 2m1, which is equals to K2, which we can write as P2 square by 2m2. Cancels out. So P1 square by P2 square is equals to m1 by m2. From here I can write P1 by P2 is equals to root over m1 by m2. Root over m1 by m2, which now finally I'll put the masses 4 by 25, right? If we look at it, root over 4 by 25, this will be 2 by 5. So 2 by 5 is our answer coming. Let us check the option. Option that is given to you is 2 by 5. Option number 3 is our correct answer. Let's look at the next question. Yeah. So the second question, if we see, this is your 29 January shift 1 question. What it says, a block of mass 100 kg slides over a distance of 10 meter on a horizontal surface. Let's draw the situation. A block of mass 100 kg slides a distance of 10 meter, right? It slides over a distance of 10 meter on a horizontal surface. If the coefficient of friction between the surface is 0.4, mu is given to us, mu is 0.4, then the work done against friction is, okay, they are asking us work done. So basically this is a simple question of work done. Let us see. Work done, friction force, work done against friction force, work done against friction force. Let us see. Over here basically if the block is moving in this direction, this is the motion side, displacement is happening towards right according to the figure that I have drawn, and friction force will be acting over here. Friction is a constant force. Due to a constant force, work done will be written as Fs cos theta. Fs cos theta. Displacement is 10 meter. Theta over here, basically angle between force and displacement is 180. So it will be work done. Let's first calculate work done by friction, and then minus of that will give us the work done against friction. So W is equals to force. How much is our force? Friction force we can write as mu into n. In this case, mu into n. Normal is how much? Normal is upward, mg is downward. Mg is equals to, so mg is 100g. From here, from the FBD, we can say normal is equals to 100g. So mu into mg, which we will get 0.4 into mg, that is your 100 into g, right? It cancels out, we are getting 400. So the value of friction comes out to be 400. Let us substitute. 400 into displacement is 10 cos 180, which is your minus 1. So work done comes out to be minus 4000 joule. This is your work done by friction. Work done against friction will be the minus of this, which will give us 4000 joule, right? So now you can check the options that are given to you. It's there in front of you people. So options are A, B, C, 1, 2, 3, that is 4000. Third option is our correct answer. Let's move ahead. Yeah. So the third question that we have is, it says the potential energy function of a particle in a region of space is given as U equals to 2x square plus 3y cube plus 2z. Okay, this is potential energy given to us. Here x, y, z are in meter. The magnitude of x component of force acting on the particle at point 1, 2, 3. Force, the x component they are asking us. Force x component they are asking us at point 1, 2, 3. Fine, well and good. How to solve this? Let's see. First of all, potential energy is given to us. We need to find out force as the function of displacement. Basically, force as a function of position we have to calculate. How do we calculate force as the force from your potential energy? The relation is force is minus of del u by del x I cap minus of del u by del y j cap minus of del u by del z k cap, है ना? Although in the question they have asked only x component, but I am doing it the whole. I am writing the full relation, complete relation, and then if only x is asked, we will only take up that part. But let's solve it completely. So this is our force from potential energy. The partial differentiation of potential energy gives us force, partial differentiation of u with respect to x, partial differentiation of u with respect to y, partial differentiation of u with respect to z. So let us see, let's do this. F force, we will get it, partial differentiation of this will come out to be minus 4x I cap. If we do this, this will be minus 9y square minus of 2 k cap. Over here j cap will also there, right? We need only x component. We need only x component of force at point 1, 2, 3. So how much it will be if I substitute x equals to 1 in this? So force x component minus 4 into 1, है ना, 4 Newton. 4 Newton will be answer. They are asking us only the magnitude, so it will be your 4 Newton. Now you check your options. Option number 3 is our correct answer, right? Option number 3 is our correct answer. Let's move ahead. Okay, our next question, it says the bob of a pendulum was released from horizontal position. Okay, let us draw this. This is our pendulum bob in horizontal position, right? Diagram is clear. Okay, 1 minute, I'll draw down little. It's so this is pendulum bob in horizontal position. The length of the pendulum is 10 meter. That means the length of the string is 10 meter. If it dissipates 10% of its initial energy against air resistance, the speed with which the bob arrives at the lowest point is. Fine. How to deal with this? So basically what will happen is, this length is given to us 10 meter. When we release it, it's fixed from here. This bob will be moving like this, right? This is the path that it will travel. This is the path. Basically it will be circular motion, vertical circular motion. It's vertical circular motion. So over here, when the bob comes from this position to this position, 10% of the energy goes in your air friction. That means basically air resistance takes away the 10% of energy. Now they are asking us velocity at this point. This is our velocity. And at this position, bottom position, they are asking us velocity. Now there are two ways of approaching it. You can do by work energy theorem also. You can use energy conservation also, considering that 10% loss. Both are possible. Let us see. One, if I use energy conservation, I'll use energy conservation. So K initial plus U initial equals to K final plus U final. Fine, well and good. Now over here, I'll take this as our reference level. Okay, the bottom, when it reaches at the bottom level, this I'll take as the reference level. That means potential energy over here will be 0. At this point, at the horizontal point, because it is released, kinetic energy will be 0. Kinetic energy will be 0, and potential energy from this level, if you notice, potential energy will be mg into the height. How much is the height? This is equals to length of string, mg into 10. One thing we need to consider over here is that finally in the final energy, in the final mechanical energy, there is a 10% loss. There is a 10% loss in form of your basically air friction is taking it. So over here we have to consider the air friction loss also, which is given to us 10% of initial energy. 10% of initial energy, this is our initial energy, U initial. So 10% of this, if I have to write, it will be 1 by 10 into mg into 10. Mg into 10. This is our 10% loss. This is equals to final kinetic energy half mv square plus potential energy at this level will be 0 only. Fine, well and good. Let's solve this. How much will be getting this? 9 by 10 mg into 10 is equals to half mv square. Okay, m goes away. This is your 5 times. This is your 2. We are getting over here 9 to 18, 180 is equals to v square. We are getting 180 is equals to v square. So v value over here will come out to be 6 root 5 meter per second, right? 6 root 5 meter per second. I hope this is okay. Over here in energy conservation, I have considered the loss of energy by air friction also. Okay. So 6 root 5 is our answer. Let us move to the next question. Yes, the next question that we have, a bob of mass m is suspended by a light string of length L. It is imparted a minimum horizontal velocity at the point A, that is your bottom point, lowest point A, such that it completes the half circle, reaches the topmost point B. The ratio of kinetic energy at A and B is basically Ka by Kb. This is what they are asking. Now this is a very standard question of your vertical circular motion, right? Very standard. Basically we need to know some results from vertical circular motion. What is that? The minimum velocity that we need to give at the bottom such that the particle reaches at the top without tension becoming 0 in the upper half. The minimum velocity that we need to give is root over 5gl. Root over 5gl, right? This is a very standard result. We have to keep this in mind. If you know it, well and good. Otherwise we should know this, right? In lectures you can see the derivation part of all these results. Vb, if we see, if over here Va is there, the minimum velocity that should be given to particles such that it completes the circle or it reaches at the topmost point is root over 5gl. And when we give root over 5gl, velocity doesn't become 0 over here. Tension becomes 0. Velocity value is root over gl. Root over gl. We can calculate also by energy conservation, applying energy conservation between point A and point B. So you will get it root over gl. Fine. We know the velocities of A and B at point A and point B. These are standard results. We will use them over here. So Ka by Kb. Particle is same only. So half m Va square divided by half m Vb square. Basically it is Va square by Vb square. How much it is? Va root 5gl, Va square 5gl. So 5gl divided by gl cancels out, 5:1. So our answer is 5:1. Check your option. Option number 2 will be our correct answer. Let's move ahead. Yeah. The question we have is, a particle is placed at point A of a frictionless track ABC. It's a frictionless track. Frictionless track ABC as shown in figure. If it is gently pushed is basically from here it is gently pushed, that means initial velocity is 0, right? The speed of the particle when it reaches the point B is well and good. Now because it is given to us that this is a frictionless curve, it's a frictionless curve, that implies no friction is there, no non-conservative force is there. We can apply your energy conservation. K initial plus U initial equals to K final plus U final. Because friction is not involved, we can apply mechanical energy conservation. Initial kinetic energy, I am applying mechanical energy conservation between A point and B point, that means at this point and at B point. Initial kinetic energy, because it is gently pushed, velocity will be 0, kinetic energy 0. Initial potential energy, now If I take this reference, that is the bottom of the curve as the reference, if we consider the bottom of the curve as a reference, the height from bottom is your 1 meter. So potential energy will be mg into 1. This is equals to kinetic energy. Kinetic energy at B point, we can write half mvb square plus potential energy at B point. How much it will be? Mg into 0.5, that is 1 by 2. When we simplify it, mg1 minus mg1 by 2, that is your mg1 by 2 is equals to 1 by 2 mvb square. M cancels out, 2 cancels out. Vb square is equals to g, that is 10. So from here we can write Vb is equals to root 10 meter per second. So our answer comes out root 10 meter per second. Let us check options. Option number 2. Option number 2 is your correct answer. Let's move ahead. Okay. The question we have is, it says, a body of mass 2 kg begins to move under the action of a time dependent force F equals to 60 I cap plus 60 square G cap. Mass is 2 kg, force is 60 I cap plus 60 square G cap, right? This is what is given to us. The power delivered by the force at the time t is given by, they are asking us power, right? Power as a function of time t. They are asking us power as a function of time t. Now power, we know two relations. Average power is given as work done by time, but and another is your instantaneous power. Instantaneous power relation is F vector dot V vector, that is dot product of force and velocity. We need instantaneous power as a function of time t. That means we'll be using this relation, force vector and velocity vector. Now force as a function of t is given to us. We need to find out velocity as a function of time t. How do we calculate? Let us see. Velocity we want, force is given to us, mass is given to us. Let us write down acceleration. Acceleration will be F by m. If we do F by m over here, it will come out to be 3t I cap plus 3t square j cap. This is our acceleration as a function of time t. Once we have got acceleration, we can find out velocity. How? This acceleration I can write as dv by dt is equals to 3t I cap plus 3t square j cap. Let's further solve it. dv will be equals to 3t I cap plus 3t square j cap dt. Let's integrate this function to get our velocity as a function of time t. So v comes out 3t square by 2 plus 3t cube by 3 I cap j cap. Finally velocity comes out 3t square by 2 I cap plus t cube j cap. We have got force as a function of t, we have got velocity as a function of t. Let us find out power F vector dot V vector. Force is 60 I cap plus 60 square j cap dot velocity 3t square by 2 I cap plus t cube j cap, right? If we do the dot product of this, we'll be getting ultimately 9t cube plus 6t power 5. Yes, this is what we are getting. 9t cube plus 6t power 5 is the power as a function of time t. Now you check the options. Options are 9t cube plus 6t power 5. Option number 4. Option number 4 is your correct answer, right? I hope the procedure is okay. Let us move ahead to the next question. Yes. So the question we have is, a train is moving with a speed of 12 meter per second on rails which are 1.5 meter apart. Fine. So if we draw the front view of it, that means like this, the situation is the trains are the tracks are, the distance between them is 1.5 meter. Okay. To negotiate a curve of radius 400 meter, basically we have this situation like this. They have to 400 meter radius is there. The height by which the outer rail should be raised with respect to the inner rail is. This is what they are asking. So first of all, let us identify what this question is all about. This question is about beta your banking, right? This question is about banking of the roads. In this case, obviously this is not road, this is the rails, but the question is about your banking. So this distance, the distance between the tracks is 1.5. They are asking us by how much it should be lifted. The outer side of the track, the outer track should be lifted by how much? This h. Let's call that it should be lifted by a distance of h, such that it can turn through a circle of radius 400 meters. So this is h, this is 1.5. Let us do, what is the relation of banking? Relation of banking tells us that tan theta is equals to v square by rg. Banking relation, tan theta is equals to v square by rg. Tan theta in this is your theta, so this is your theta. So how can we write it? Tan theta will be h by 1.5. This is equals to v square. It was given to us. What was value of velocity given? It's there for you people. 12 meter per second. Okay, 12 meter per second is given. So velocity is 12 meter per second. 12 square 144 divided by r into g, radius into g, that is your 400 into g, that will be your 4000. When you will solve this, h value 144 into 1.5 divided by 4000. When you will solve it in the options, if you see, the answer is given to you in centimeter. Over here it will come in meter. Finally, when you will convert into centimeter, this will come out to be your 5.4 centimeter. Right? Direct formula based question, just we need to imagine the diagram, visualize the diagram carefully and use our banking relation. Right? So answer will be your 5.4 centimeter. Let us move ahead. Yeah. Our question is, if the radius of curvature of path of two particles of same mass are in the ratio of 3:4, radius of curvature, let's take R1 and R2, are in the ratio of 3:4. Okay. Then in order to have constant centripetal force, their velocities will be in the ratio of, constant basically over here implies the same centripetal force. So F1 equals to F2. Then what will be the ratio of their velocities? Masses are given same only, right? Mass is given same. Let's see. Force centripetal, what can we write it? M into V1 square by R1. Centripetal force is mv square by r, is equals to m into v2 square by r2. Because masses are given same, I have taken mm. Now, so we want to find out velocity. So v1 square by v2 square is equals to r1 by r2, which gives us v1 by v2 is equals to root over r1 by root over r2. Basically the root of radius of curvatures. If we substitute, this will be root over 3 by 4, which gives root 3 by 2. Answer. Alright, you can check the option. Option is option number 1. Option number 1 is our correct answer. Let us move ahead. Yes. So the question we have is, a particle is moving in a circle of radius 50 centimeter. Okay, let us take the data. So radius is 50 centimeter. Now 50 centimeter we can write as your basically 1 by 2 meter. Okay, in such a way that at any instant the normal and tangential component of its acceleration are equal. Acceleration normal is equals to acceleration tangential. Obviously magnitudes will be equal. The magnitude of normal acceleration, which is basically your centripetal acceleration, and tangential acceleration are equal. Fine. If its speed at t equals to 0 is 4 meter per second, at t equals to 0, v value is 4 meter per second. The time taken to complete the first revolution will be 1 by alpha 1 minus e power minus 2 pi. So t is 1 by alpha 1 minus e power minus 2 pi. This is what the time taken to complete one revolution, that is the distance of 2 pi r, where alpha is. They are asking us alpha. Now beta, interesting question. Observe over here what we are doing. So let's see. The condition that is given to us is this, that acceleration centripetal, that is normal acceleration, and tangential acceleration are equal in magnitude. Now normal acceleration, what do we know? Normal acceleration can be written as v square by r. V square by r is equals to tangential acceleration. Tangential acceleration is rate of change of speed, not rate of change of velocity. Tangential acceleration is rate of change of speed, which I'll write as dv by dt, right? Let us simplify this. So I can write it over here. If I rearrange this, dv by v square is equals to dt by r. Okay, r is your 1 by 2. So now if we integrate this, now please remember this v is over here speed, not velocity. So dv by v square, if we integrate it, this r is basically 1 by 2, so we'll get 2 over here, which I'll take outside of the integration. Now at t equals to 0, the velocity is given to us 4. Okay, at any time t, let's say velocity is v. If we integrate it, we are getting over here 1 by v square will be minus 1 by v. Limits are 4 to v. This is equals to 2t. Let's simplify. Minus 1 by v plus 1 by 4 is equals to 2t. What do we get it? 1 by v is equals to 1 by 4 minus 2t. Further, we can write down 1 by v is equals to 1 minus 8t by 4. So from this I can write v is equals to 4 by 1 minus 8t. This is speed as a function of time t, we got it. It's visible to you? Or sorry, this steps I'll write over here. 1 by v is equals to 1 minus 8t by 4, and from this we can write v is equals to 4 by 1 minus 8t. This is your speed as a function of time t. We have got speed. Speed can be written as your rate of change of distance, which is ds by dt. Okay, rate of change of distance, I have taken the variable as s. So ds by dt is equals to 4 by 1 minus 8t. Let's rearrange this. ds is equals to 4 by 1 minus 8t into dt. If we integrate this, function over here, integral ds, we are integrating distance over here from 0 to time t, when you are one complete revolution means distance traveled will be how much? The circumference, one circumference basically 2 pi r. So we can write over here, this will be 2 pi r. This integration of 4 is constant, so we can take out integral of 1 by 1 minus 8t. This will come out to be ln 1 minus 8t by minus 8. Limits are from 0 to capital T. Capital T is basically the time when your one round is completed. This is what we have got it. So 4 times minus 2, it comes over here, minus 4 pi r is equals to ln of 1 minus 8 into capital T. Okay, r value is 1 by 2. I hope it's visible down here. Okay, so let us solve it. Over here r value is 1 by 2, so we will get it minus 2 pi is equals to ln of 1 minus 8t. Let's simplify this. So this we can write it 1 minus 8t is equals to 1 minus 8t is equals to e power minus 2 pi, which we will get it 8t is equals to 1 minus e power minus 2 pi. So t is equals to 1 by 8, 1 minus e power minus 2 pi. This is what is your time coming, right? This is what is your time taken to complete one round is coming. Now if you check with our this answer that was given to us in the question, your alpha value, if you check it, alpha value will come out to be 8, right? So our answer for this is alpha is equals to 8. I hope you got the solution. It's a good question. Let us move ahead to the next question. Yeah. So our question, circular motion question, let us see. A stone of mass 900 gram is tied to a string and moved in a vertical circle of radius 1 meter making 10 rpm. Let's write the data that is given to us. Mass is 900 gram, radius is 1 meter, and velocity is given to us as 10 rpm. That means it's your angular velocity. This is angular velocity 10 rpm. Well and good. They are asking us the tension in the string when the stone is at the lowest point is pi square is 9.8, g is 9.8 meter per second square. Okay. So if you notice carefully, what will happen the situation? A particle will be moving like this. This is the situation, particle will be moving. At the lowest point, if we draw the FBD, tension upward, mg downward, right? Over here, so what equation we can write? Force equation if we write, T minus mg is equals to mass into acceleration centripetal, which is r omega square. I hope it's okay. R omega square, right? Let's substitute. So T is equals to mg plus mr omega square. M can be taken common. This can be written as g plus r omega square. Now mass is 900. This can be written as 9 by 10 kg. G is 9.8 plus R is 1 meter, omega square. If you notice carefully, omega square, omega is given to us 10 rpm, which is revolutions per minute. If we have to change it into radian per second, if we have to change it into radian per second, we should multiply by 2 pi by 60, right? How much we are getting it? 6 times. So this comes out to be pi by 3 radian per second. So omega is pi by 3 radian per second. So we can square it, pi square by 9. Fine, well and good. So we get over here T is equals to 9 by 10 into 9.8. Again, pi square value they have given in question. Take pi square as 9.8. So 9.8 by 9. We can take 9.8 common over here. 1 plus 1 by 9. 9 by 10 into 9.8 into 10 by 9. 10, 10, 9, 9 cancels out. Tension value comes out to be 9.8 Newton. Right? 9.8 Newton is our tension. So let us check. Option number 2 is our correct answer. Let us move ahead. Yeah. So a question, work done question has come in between circular question. Let's see. A block of mass 1 kg is pushed up a surface inclined to horizontal at an angle of 60 degree by a force of 10 Newton parallel to the inclined surface as shown in figure. I have drawn the figure in front of you, and you also have for you people. When the block is pushed up by 10 meter along the inclined surface, work done against frictional forces. It's a simple question, long question, but it's a simple question. Displacement is given to us. Displacement is 10 meter, right? They are asking us work done against friction. Let us calculate friction force. Friction force will be what? Mu into n. Friction is mu n. In this case, in case of incline, normal up, over here we will have mg cos theta, and this side we will have mg sin theta. Obviously, if the block is going upward, the friction will be acting down the incline. And friction will be acting down the incline. This, and friction value is mu into n. In this case, we can say that normal is equals to mg cos theta. So mu is our 0.1, normal is mg cos 60. Let's put it 1 by 10, mass is 1 kg, g is 10, cos 60 1 by 2. So our friction value comes out to be 1 by 2. So work done will be force into displacement. Force is your, we got it 1 by 2, and displacement is 10. So we will get over here 5 joule. And they are asking us work done against friction. So obviously work done by friction will be minus 5 joule, but work done against friction will be 5 joule only. Let's move ahead. Yeah. So the last question of this video, let us see. It says a coin is placed on a disc let's draw the situation. A disc is there. A coin is placed on a disc. The coefficient of friction between coin and disc is mu. So over here, let's suppose somewhere a coin is placed and the coefficient of friction is mu. If the distance of the coin from the center is small r, this distance is small r, then the maximum angular velocity which can be given to the disc so that coin does not slip away is fine. So beta, if you notice carefully, what they are saying, they are asking us omega value. What can be the maximum omega such that this coin does not slip away? So when we will be rotating, the coin will also rotate along with the disc. When we rotate the disc, the coin will also rotate along with disc. And to rotate, for the rotation motion of coin, there requires a centripetal force. There is only one force which can act along the surface, which is your friction force, which is your friction. To be specific, it is the static friction which will be acting towards the center and provide the necessary centripetal force to coin for its rotation motion, right? So force centripetal is equals to force static. Maximum value of static friction is basically our limiting friction, right? So let us write down friction limiting is equals to force centripetal. Limiting friction value is mu into n. In this case, it is mu mg. The maximum value of limiting is, or maximum value of static is basically mu mg. In this case, normal is mg. So mu mg is equals to force centripetal m r omega square. So over here m and m cancels out. Omega square is equals to mu g by r. So omega is equals to root over mu g by r, right? This is the maximum value of omega, the angular speed that can be taken such that your coin also rotates along with it. Till this omega, the coin will get the necessary centripetal force. If we increase omega, after that static friction cannot provide the required centripetal force, then the coin will slip away. So this is the maximum value of omega till which it will not slip or till which it will rotate along with disc. Fine. So check the option also. For you people, it's there. For me, it is option number C. Option number C, root over mu g by r. Option number C is our correct answer. I hope you found the video helpful. You learned something from it, right? Do consider to press the like button, and also you can check the previous videos also which we have made on your kinematics PYQ, NLM PYQ, ray optics PYQ, and in coming days we'll be uploading the PYQ of different chapters also, right? Thank you very much. Bye bye.